talking about functor last time, and we're gonna build on that. Talk about another type class called applicative that that gets used all over the place, and it's yeah. Functor is one of those things that, like, it's a useful tool and it's good to know about, but you can't like build a whole library on top of the idea. But applicative, which we're going to talk about today, start talking about, is in some sense much more powerful, and you can actually, there's a lot you can do with it, just using that interface. So, by way of Alright, but let's introduce the idea first. So, let's suppose that I have let's say so let's say, I don't know, maybe the string represents like their name and the integer represents their salary or something like that. Okay? So I've just got this data type to represent an employee. So obviously if I have a string and I have an integer and I want to put them into an employee record, I just use the employee constructor and I get an employee. What if I have a maybe string and a maybe integer? For example, maybe I was reading this information from a file, and it's possible that the file was not formatted correctly, or maybe the file didn't exist, or maybe I was getting them by calling some website to get some information, and like it could have returned an error, or the internet could be down. Who knows, right? There might be some reasons that I may or may not have a name, and I may or may not have a salary. And the question is, obviously I can't hope to put them together into an employee, because I might not have the information I need. But it seems reasonable that I could get a maybe employee. Right, so can I put them together into a maybe employee? In other words, can I write a function of this type, maybe string, maybe integer, so maybe employee? So, what do you think? Do you think you could write a function of this type? So I hope the answer is yes. And it's not too bad, right? If you just start pattern matching on things, you're just like, well, okay, if the first thing is nothing, I don't care what the second thing is, I can't, in that case, I can't make an employee, so I'll just say, actually, you know what, let's even write it in a simpler different way. We can say, if the first thing is a just name and we have a just salary, then I can return a just employee name salary. And otherwise, I'm just going to print nothing. So that handles all the cases where like one or both arguments are nothing. Okay, fine. What if I have a list of names and a list of salaries? And now there's there's questions about how this should work. So maybe do I just like kind of match them up, like the first name with the first salary, the second name with the second salary? Or for some reason, do I want to like pair them up in all possible ways, like put every name with every possible salary, we get like a whole bunch of. It kind of depends what I'm doing, right? So like this. Could I get a list of employees? And sure. There are several ways we could this. It doesn't really matter exactly what it does. That's not my point. My point is, for sure, we could write a function like this that would, somehow put a list of names and a list of integers together and get a list of employees. You know, you could get like what if I have, so what could this mean? So imagine that E is some kind of, it's sometimes, maybe it's like a giant record representing like my whole database or something. And I somehow have a function here, I have a way to like extract a name from that information, right? Maybe it's just like, think of E as like, maybe it's a file that had a whole bunch of data in it, and I read in the contents of the whole file, and I just have a way to extract like the name from that. And I also have a way to extract a salary. Could I put those together into a way to extract an employee? So like, call it employee. Right. So in other words, if I can extract a name from whatever E is, and I can extract a salary, can I extract an employee? Sure, because I could extract both the name and the salary, and then I could put them together, right? So, you know, I could just say like, I'll call this get name. No, I should call this get employee, not to. It's like a getter function. It's like you get an E, you're getting an employee out of it. So if I have a way to get a name and I have a get salary, then I can say, take the E as an input, and then we're going to say make an employee out of get name E get salary. Okay. Again, the actual implementation is not important. The point is there's a lot of different ways that I can imagine if I don't just have a bare string and an integer. If I have a string and an integer in some kind of context, I can kind of put them together to get an employee in the same kind of context. So, can we generalize? So I want some kind of like, we'll say, so the question really is like, for what kinds of F can I do this? Right, so we've seen that we can do this for maybe, we can do it for list, we can do it for, you know, E arrow, whatever. So that's the question, like, for what kinds of and we can say more generally, for what kinds of, I don't want to say kinds, because we know kinds has a technical meaning, and that's not what I mean. So more generally, forgetting about employees, if I just say, you know, I have a function that takes an A and a B and gives a C. I have a way to combine, you know, some pieces of data to get C. And in our case, C was employee and A was like string and integer. Can I kind of lift that up to work on, you know, F things? We'll call it, I'm going to call it fmap too, because if you look at the type of this, you're like, oh, that looks pretty familiar. Like that looks a lot like fmap. Fmap said you have an A to a B, and then you get an FA to FB. And this is like, well, it's kind of like fmap, but for like two argument functions. So if I have a way to combine things, an A and a B into a C, can I lift it up to work on Fs? So we might hope that this would work for any function. You're like, well, we'll just use fmap twice or something, right? You can probably already guess that's not going to work just because I said we're going to talk about something other than functor. But let's try it and kind of see what goes wrong. And that's also going to help us figure out what extra everything we need to be able to do this. Okay. So let's answer no, but let's try to see what goes wrong. This is not actually called fmap2 in the standard library, but it's a perfectly good name. So let's take our function. We'll call this function g. That's our a to b to c function. And of course, these parentheses are kind of like they're redundant. We don't actually need this. So I can just say, all right, we're going to take our fa as an argument. We'll take our fb as an argument. So we have g, which has type a to b to c. We have fa has type fa, and fb has type f. And then we want an fc. Okay. And we know that f is a function, so we can use fmap. I mean, if we didn't even have functor, then we would just be completely stuck at this point. There's not much we can do because, to use g, I would have to apply it to an a and b, but I don't even have this. So there is one thing we can do, and we have to recall that this function a to b to c, it really means this. It's a function that takes an a and returns a function from b to c. So anyone see there's one thing that we can actually do with what we have so far. How can I use my function g? I don't have something of type a, so I don't have something that I can literally just apply g to. But I can use fmap. So remember, fmap has the type. We'll use some different letters so we won't get confused with our a, b's, and c's. But let's say s to t. But it is the same f that we're thinking. Okay, so you're saying, what if this was FB and this was FC?
Yeah.
Then what type of function would I need to give it? B to C, right. And that seems tantalizing, right? Because here's a B to C function here, but I would have to give it an A first to get the B to C, and I don't have an A. So that's a great try. I mean, this isn't going to work, right?
Yeah.
So like, it's not like. So no, let's check that there. So one thing we could do, we could say, fmap question mark fb would have type fc, meeting. Maybe I'll say like question mark. think about like what we want at the very end. We could just think about like what we could give to fmap. Maybe we could just do like one step that would get us a little closer. So fmap takes a function. I have a function here. So like, can I do something with fmap g? Right, that'll be another thing to try. So if I say fmap g, what type would that have? What would be S and what would be T? S would be A. Yeah, T would be B to C. So once I apply fmap to G, I would be left with this part, fs to ft, but fs would be A, and this would be, right. In other words, right, fmap G takes this function G and lifts it up to work in F world. So instead of going from A to B arrow C, it goes from FA to F B arrow C. Okay. Put in another way, well, okay. So, and then notice that I actually have an FA, right? So I can actually apply this to an FA. So then I could say fmap G applied to FA would have type F B arrow C. Right? This is also tantalizing because we were just seeing before that we needed, if we could get a B arrow C function, then we can use fmap again to get the thing we want. This isn't quite a B arrow C function, right? It's an F B arrow C. So think of it like, it's some data structure full of B to C functions. Right? So maybe it's like a list of B to C functions, or it's a maybe B to C, so maybe we have one every day. Right, so in other words, kind of what this is doing is we had some F structure full of A values, and we did fmap G, and so that turned all the A values into B to C functions. So now we've got a structure full of B to C functions. So we've got a structure full of B to C functions, and we've got a structure full of B's. So now we have okay, so now we have F B to C and F B. And we need F C. Right, and this, again, seems kind of tantalizing. Like, we've got a structure full of functions from B to C, and we've got a structure full of B's. It's like, can't we somehow just, like, apply these functions to these B's and get some C's, right? That's kind of what we want to do. But it turns out, like, functor just isn't enough. Like, functor only tells us if you have one F structure, one data structure, you can apply a function, everything in it. But it doesn't really tell us anything about how to combine two of them, right? Because that's what I need to do here. I have two F structures, one with functions in it, one with arguments in it. I need to combine them to get a new F structure. Functor doesn't give me that part. So we need to combine a data structure full of B to C functions with another data structure full, I'll say an F data structure full of arguments of type B, and get the structure of C's. Right, but functor gives us no way to combine F's. Okay. Does this make sense? Any questions so far? So, again, stepping back, big picture, we wanted something that's kind of like fmap, but for two argument functions. But it turns out that functor is not enough to give that to us. just went through actually suggests what we need to make this work, which is we need this way to combine, like we need a way to combine F structures. So we need a way to say, in particular, like if I have one structure full of functions and another structure full of arguments, can I combine them and get some results? All right, actually, let me see. I think if I hide it, then we can just define it ourselves and it won't go. So that's what we're going to do. And this is called, this is often pronounced app. Or sometimes I've heard people call it slat. And it's exactly this. So, well, I'll rewrite it like this, just so it lines up. Okay, this just says, yes, something is applicative if there's a way to take two structures, one full of functions and one full of arguments, and combine them. And kind of apply the functions to the arguments in some way, and you get the new F thing out. Turns out there's one other thing in applicative, and I don't have as good of a way to motivate this, but it turns out that we often want this. So we'll see some examples of what. Here just says, hey, if you've got an A value, we can kind of create some kind of singleton F thing, or not necessarily singleton, but just like a kind of default F thing that just has that A value in it, and nothing else. And if we line up the types of these, like kind of like fmap 0, if you think of it that way. Like fmap is for one argument functions, takes an A to B function and turns an FA and an FB. So you see how here kind of lines up here? Instead of taking a function, I just take a value type A, which you could kind of think of like a function of 0 arguments. It's not really a function, but, and then it just gives us an FA. So, fmap2, let's just tie this loop off, and then we'll just show that, yes, indeed, we should be able to do this because that's kind of where we got the idea for this operator from, was the fact that that's what we needed to finish our fmap2. So we should be able to implement fmap2 now using applicative. Oh, I forgot a very important thing, which is that basically everything that's an applicative has to also be a functor. And we'll see in a minute, I think, that there's actually a very, very good, it's not just like, well, that's kind of just what we want. There's actually a really good technical reason for this, which is that it's possible to implement fmap if you're only given these two things. You can actually write fmap. So if you have these two things, it's automatically going to be a functor anyway. So might as well say that. We'll see that. But, so fmap2, right? We can do just what we were doing up here and say, all right, we'll take our G, our FA, and our FB, and we say fmap G FA. Right? That gives us our that gave us something of type F, B to C. And then this operator says, yeah, you can, if if you have one of those, you can combine it with an FB, and you can get an FC. And so, if I just say, that should have the right thing. Now, it's not clear what this does, or like, you know, can we make an instance of this? I mean, maybe like there's nothing that we can make an instance of this, and so we'd be like, well, that's dumb. But, of course, there are lots. So let's do some examples. Let's first try maybe. Maybe is like the first example I always try of anything because it's like the simplest data type that's not completely trivial. So pure will have type A to maybe A, and app will have type maybe to maybe B to maybe C. So what do you think? How should I implement pure? There's actually two different ways I can imagine implementing it, and you tell me which you think makes sense.
Can it just be just? That's something that's,
Sure. I guess so I could just say pure equals just. Yeah. I could also say pure A equals nothing. That has the right type. Number one, that feels a little stupid because I didn't use the A at all. Number two, it turns out there's going to be something that we want to require. There's some like laws that we want to require that instances should satisfy, and now the nothing one wouldn't work. But even just from the like stupidness arguments, like this clearly is the right one because it seems dumb to completely ignore the A. Just read it out. All right. So how about this? So I've got I might have a B to C function, and I might have a B, and I want to maybe get out of C. Now again, I could just say ignore the arguments and return nothing. But again, that seems pretty stupid. Let's try hard to produce a C whenever possible. And only if we like can't possibly do that, then we'll opt in nothing. Okay, so what should I do? Not a trick question.
if you don't have a B to C, then you can't do it.
Yeah, okay, so the first thing is nothing, I can't do it. So if this is like nothing, whatever, there's nothing I can, nothing. No, I can return nothing, that's something. I can't possibly get a C because I don't even, I might have a B, but even if I did, there's nothing I can do with it because I don't have a way to turn B's into C's. Okay, so this will be nothing, all right? What else? Yeah, but the only way I'm going to be able to make a C is if I really do have a B to C function and I have a B. That's the only way. So we could even like flip it around and say, all right, let's just do the just case first. That's the only case where we're going to get a just. So we'll say if it's just a function G and just a B, then I'll return just G. And otherwise, in all other cases, and let's try this. So, you know, I could use my fmap2 and say, you know, let's try adding two maybe ints. Right, so fmap2, so for my A to B to C function, I'm going to give it plus, which takes two ints and gives an int. And then I'm going to give it a maybe, you know, two maybe ints. So like, you know, if I say nothing, just free, I say nothing. exactly kind of what we were thinking, well, I could even do it with employee, right? So I could say fmap2, so employee is this constructor, which we can think of as a function that takes a string and an integer and builds an employee. So I could say fmap2 employee, and then, I could say, well, if I've got a, nothing, and then just empty. So, nothing, right? But if I say, just, so at least in the case of maybe, this is doing exactly, I mean, if you look at our definition of maybe employee, it looks very similar to our definition of the app operator for maybe, right? But the app operator is much more generic. It doesn't only work for maybe, and it doesn't, well, I guess our implementation of app did work for just maybe, but it didn't only work for strings and integers and employees. And actually, if you look at this, you're like, well, if we just take this part as a parameter instead of like building this in, then we basically get, like this doesn't only have to work for the specifically building employees. You give me any function and okay. Right, but you can imagine this kind of thing happening a lot where with maybe specifically, it's like if you're getting multiple values and you want to combine them according to some function, but also there's reasons why you may or may not have those values, right? Like maybe there was just some possibility of an error or them not being available or whatever, and you want to say, if I actually have all the values, if everything has gone right so far, then here's how I want to combine them. But otherwise, I will just propagate the fact that something failed and I'm not getting a result. That's a really common thing to want to do. And it's nice to have this way to do it without, you don't have to I think before, you would have just written a case. You're like, well, if I've got nothing, then do this. But we don't have to using this tool. Let's do another instance. Let's do, I don't know. List or, well, let's do this one next, actually. This one, it maybe feels a little more complicated, but it's actually more straightforward than lists. So we can write down the types of things we need. So we need pure is going to have type A to this thing applied to A, which is really like E to A, right? And then app is going to take a function from E to A to B function. And then I should call it, we can call it B to C. So I think if you actually look at the definition of applicative in the standard library, it doesn't say B, it uses A and B instead of B and C. But I'm just using B and C to be consistent with the variables we were using in our example earlier. And then it takes an E to B function, and it returns an E to C function. Right? So again, it's something B to C, something B, and it gives us a something C. In this case, the something is this E arrow. Okay. Well, how about this one? Just look at the types and think about this. Like if I get an A, and of course we don't really need this. Get an A and an E, and I'm going to get back an A. Well, fine, I can just ignore the E. Just return the A. So this kind of corresponds to, if we think of this as being like values that you know how to extract from some big record or some context, right? Pure says I just have a value. I don't need to extract it. I just have it. So I can ignore the context. I don't need to do any extracting. Just here it is. Okay, and then what about this? So this says, hey, if we know how to extract a function from B to C, and we know how to extract a B, then we can kind of extract both and apply the function to the B, and that'll give us a way to extract a C. So, again, let's see, we'll call it G, I'll call it G and H. Well, let's see. I need to make a function from E to C, so I'll say lambda E. And now I need to give C. So I can, well, what do you guys think? So at this point, I've got G is an E to B to C, H is an E to B, and E is E. And then I want a C. How can I put those together to get a C?
H to G.
H to G.
The output of H.
The output, okay. So I'm going to have G applied to some things, right?
Because you have E to B to C, and
Right.
then H gives a B,
Right.
or gives E to B. So you can give that B to the B to C function to get back to C.
Okay, right. So G is going to return a C, so that's what I want. So I can call G. I need to give it an E, which I have one. I can just copy it. I also need to give it a B, which I can get from H if I do H applied to E. Like that. So let's try this out. So let's see. Let's say record is well, we'll call it file. Is Carl. Just don't remember all this. Yeah, I don't know. Let's say I literally read this from a file. Okay, so I've got this string representing the contents of the file. The first line is the employee's name. The second line is their salary. So I can make a get salary function that says, you take head.lines. So it first splits the string into lines, then just gets the first line. That's their name. Sorry, get salary. We can get their salary by, again, we break it into lines. We get out the thing at index 1. And then, well, that's a string, so then we call read to turn that into an integer. So then, well, let's just try this. So we can get salary file. Oh, what happened? Oh, I know. Let's just do it. The thing that happened is that since it didn't know what type I wanted get salary to output, it just assumed that I wanted, well, get salary, I guess, is like, yeah, I can output anything that you can read, which makes sense, but then when I tried to use it here, I think it just assumed that I wanted like the unit type or something, and it's like, yeah, 100, I can't read that into a unit value, and so, we can fix this by actually, if we give a type signature to get salary, it's like, no, I want an int out, or an integer, whatever, integer. Then it's like, oh, fine, an integer, okay. So, takes the contents of a file and gives you an employee record just by saying, this is going to be fmap2 employee. It's going to do the exact same thing as our get employee up here already did, but so it ran both, combined them into one. So I think if this was all it could do, then it would be like, well, I guess that's kind of nice, but like, what if I've got an employee, what if the employee record has 3 fields in it? You know, then I guess I want like an fmap3. Am I going to need another type class for like Applicative 3 for that or something? Right, so this is what I want. Like, what if I have 3 pieces of data that are going to be combined here? And so I actually have an FA, an FB, an FC, and an FD. And I want an FD out. Like, is Applicative enough to do this or not? And if it's not, that's going to suck, because then it's like, well, we're going to need a new kind of type class for each, fmap n that we want. And it's like, well, if you add a field to your employee record, well, now you've got to change, what you were doing because you EDD the different. However, as you may see, we don't. So let's take our function G, and FA, and FB, and FC. So we know from before we can do like, if I do fmap G FA, right? So G really, it's a function that takes an A and returns, a B to C to D. So if I say fmap G over FA, I'm going to get an F B to C to D. Or really, this. Okay, let me take these things again, but I'll just say that G is A. Okay, and I've got an FB, and I've got an F containing of functions from B to something. So I can use that app operator. So if I say fmap G FA app FB, right, that should give me something of type, well, I have this F thing full of functions from B to whatever, and I've got this F thing full of arguments of type B, so I'm going to get an F full of the output, which is C to D. And that actually is looking pretty good, because now I've got an F full of functions again. And I can use app again to apply that to the FC that I got. Right? But then we can use app again. So this thing applied to FC with app will just have type FT. That's exactly what we want. So, and type checks. And hopefully you can see at that point that like we could keep doing this. We could keep iterating that as many arguments as we have in our function. We keep iterating that process and just say app to all the things, and it would be good. So it turns out, thankfully, no. Like having app, just being able to combine 2 things into one is enough. You can iterate that to combine any number of things you want. So next time we'll do a bunch more examples of that. But we'll also see like there's kind of we can do some work making this look a little nicer, and it'll give us a nice template for how to use this in general. Because actually literally going around using functions like fmap3, fmap5 is annoying. But there's a nice way we can write it